Hey everyone, welcome back to my channel. Today we are going to dive into some advanced techniques to boost the performance of your Entity Framework Core applications. If you are working on large-scale ASP.NET Core projects and want to make your database interactions faster and more efficient, this video is for you. I'll be covering essential strategies from optimizing queries to handling bulk operations that can make a huge difference in your app's performance. Plus, you can download the complete project with all these improvements from my GitHub account. Link in the description below. In this video, we'll explore several important techniques to improve EF Core performance in ASP.NET Core projects. Number 1. Lazy connection string initialization. Find out how to defer the initialization of your database connection string until it's actually needed, reducing startup overhead. Number 2. Disabling lazy loading. Discover why lazy loading can hurt performance and how to manage data loading more efficiently. Number 3. As-no tracking. Learn how to optimize read-only queries by disabling entity tracking for faster data retrieval. Number 4. Eager loading with include. See how eager loading can reduce unnecessary queries by loading related data in a single call. Number 5. Compiled queries. Find out how to reuse compiled queries to improve performance in frequently run queries. Number 6. Bulk operations with execute update. Simplify and speed up bulk updates with execute update method. Number 7. Optimized pagination. Learn how to implement efficient pagination by applying a skip and take before materializing data. Okay, so stick around to see practical example of each. Let's get started and level up your EF Core skills. Okay, before we dive into EF Core performance optimization, let's quickly look down the current architecture structure that I'm using in this application, in this project. If you are not familiar with it, don't worry at all. This will give you a clear understanding of how the project is organized and why it's important for building applications. First up is the core layer, also called the domain layer. And this is the heart of the application. Here we define the entities, enums, and basic business logic. And think of it as the what of your app, the rules and models that don't care about databases or APIs, just the core functionality. Next is the application layer. This is where you will find the use case of your app. Basically, the actions your app can perform, like get products or update customer or delete customers and things like that. It also has interfaces for services. Of course, I should mention that I've completed some parts of the project because they were necessary. For example, I finished the sections related to application layer and other parts of the project. This layer is responsible for your business logic. Here we have infrastructure layer. The infrastructure layer is where all the technical details live, like database access, such as EF Core or Dapper and things like that, external services, file storage, and more. It implements the interfaces defined in the application layer. This is where the big things happen when your app needs to talk to the database or external systems. Finally, we have the presentation layer, or in this case, the web layer, web application. This is where the app communicates with the outside world through APIs or user interfaces. In a web API ASP.NET Core application, this is where you will find your controllers and anything else related to the HTTP requests. Okay, let's start with the basics here. The first thing we need are our essential namespace. We are using Entity Framework Core for our database context, iConfiguration to access the connection string from appsettings.json, and of course system, because we will be using the lazy generic feature for our connection string management. Now here we go. This is our application DB context class, which will serve as the heart of our interaction with the database. Notice the use of lazy string. What this does is delay the initialization of our connection string until it's actually needed. This approach is called lazy loading, and it can be a big win when you want to save memory or avoid unnecessary computations when the connection string is not immediately needed. Notice the key part here. We are using configuration builder to load app settings.json on demand. This approach ensures that we read the configuration only when it's actually requested. So if our database context isn't used right away, we aren't wasting any time on unnecessary operations. And of course, we are adding a fallback connection string. So if there is an issue, our app doesn't just crash. This is good practice, especially when deploying to multiple environments where connection strings might vary. Here we are exposing this lazy loaded connection string as a static property. This is killing because it means that no matter where you use this connection string, it will only ever be initialized once the first time you access it. In simpler terms, the lazy loaded string will only be set up the first time you need it, and then reused from memory. This is handy for applications that require consistent configuration across multiple parts. Okay, here we have the constructor that EF Core uses when setting up dependency injection. This allows us to configure our DB context from outside of this class, usually in program.cs or startup.cs. By handling the options from outside, our application DB context remains flexible and easy to configure. Now we get into the main parts of our database context by defining dbset properties. Here we are essentially mapping our database tables to our product and category entities. This gives us a strongly typed access to these tables and lets EF Core handle most of the underlying SQL. And finally, we override the unmodel creating method even though it's currently empty. This method is crucial for customizing EF Core's conventions, setting up complex relationships, or configuring additional mapping details for our entities. We can use it to apply things like default values, constraints, or more complex mappings that might not be straightforward to handle with just attributes on our models. Alright, let's get back to our program.cs file and see how to register this service. So what we are doing here is adding the application DB context to the service container using dependency injection. This is a key concept in ASP.NET Core where we register all the services we want our app to use. The DB context is registered like this so that it can be injected into controller or other services when needed. Notice we are calling use SQL Server. This tells EF Core that we want to use SQL Server as our database provider, and we are passing in application DB context.connection string. This is the lazy loaded connection string we talked about earlier. Here where we were initializing our connection string for the first time through lazy generic class. As we covered before, the connection string is being loaded lazily, which means it will only be initialized when it's first accessed. This is great because if the DB context isn't needed right away or maybe isn't used in certain requests, the app doesn't waste resources initializing it prematurely. Okay, now we've covered the lazy loaded connection string. Let's quickly dive into the lazy loading proxies part. First, what is lazy loading in Entity Framework? When you are enable lazy loading, EF Core automatically loads related entities the first time you access a navigation property. For instance, if you have a product entity and you access its category navigation property, lazy loading will automatically fetch the related category from the database. This is super convenient because you don't need to manually write queries to include related data. However, there is a catch. It can lead to performance issues like the famous n+1 query problem. For example, if you load a list of products and then loop over them to access each product's category, lazy loading will trigger one query for each product, resulting in n+1 database queries. Now, in this case, we are setting use lazy loading proxies false, meaning we are disabling lazy loading proxies. Because in performance critical applications like the one we are building, eager loading or explicit loading is often a better choice. When lazy loading is off, you have more control over what data is retrieved from the database. You can explicitly tell EF Core to load related data using include statements. This reduces the number of database queries and gives you fine-grained control over how data is fetched, which is key to improving performance. For example, you can use something like this when querying your data if lazy loading is disabled. Here we are explicitly telling EF Core to include category data when loading products. This is eager loading and it avoids unnecessary queries later on. Alright, now that we've learned how to work with lazy loading and even the lazy loaded connection string, let's shift gears and focus on a couple more essential optimizations. I mean, as no tracking and optimized pagination. These techniques can make a huge difference in the performance of your EF core queries, especially when working with large datasets. First up, we have ASNO tracking. This is one of the most powerful tricks you can use for read-only queries. So what's going on here? Normally, when you query data in EF Core, it tracks every entity that's returned in memory. This is useful when you need to update those entities later. But in case where you are just reading data, this tracking adds unnecessary overhead. By using ASNO tracking, we tell EF Core we don't need to track these entities. We are just reading them. This removes the tracking overhead, making your queries significantly faster and reducing memory usage, especially when dealing with large datasets. So anytime you know you are just fetching data and don't need to update it, always go for ASNO tracking. It's a small change, but the performance benefits can be huge. Here, as you can see, we are also using include method for eager loading. We talked about this earlier. This is simply telling EF Core to include related data upfront, avoiding multiple database trips. In this case, we are fetching both products and their related category data in one go. Simple and efficient. Next up, we've got pagination. Now this is key when you are working with large datasets. Instead of loading everything into memory at once, we only fetch a small chunk of data. Let's say 10 or 20 items at a time using a skip and take. This technique is essential for performance and responsiveness, especially in web applications. So here's how it works. We first use skip page number -1 multiplied by page size to skip over all the records from previous pages. For example, if we are on page 2 and each page has 10 items, we skip the first 10 products by using skip 10. And then we use take page size to grab only the number of items we want to display on the current page. For example, 10 items. This keeps the database query light and efficient, fetching only the necessary data for each request. The beauty of this approach is that it reduces memory usage and speeds up query performance, especially when dealing with thousands or even millions of records. Alright, now that we've covered ASNO tracking and optimized pagination, let's move on to another really powerful feature for performance optimization in EF Core. It's called compiled queries. This is especially useful when you need to repeatedly execute the same query multiple times, like fetching data by ID in this case. So here's a quick example of how you can implement a compiled query. First, let me walk you through this code snippet. Instead of EF Core building the query from scratch every time you run it, which can be a little slow, we pre-compile it. This means EF Core prepares the query once, and then whenever we call it, it's ready to go. No need to rebuild the query each time. In this example, we are creating a compiled query to get a product by its ID, and we are using ASNO tracking again because we don't need to track changes for a simple fetch operation. Notice how we use ef.compile async query, which helps us compile the query in an asynchronous fashion. This is great for scenarios where you are executing the same query multiple times, especially in high performance applications. Next, let's look at how we use this compiled query in our get product by ID async method. Here, it's simple. We just pass the context, the product ID, and the cancellation token to our precompiled query. This means we are executing the query much faster than if we were to build it from scratch every time. So why bother with compiled queries? In my view, in performance critical applications, especially ones where you might be running the same queries over and over, this can save you a lot of time. EF Core won't have to constantly parse and optimize the query every time you need to fetch data. It's just a ready-made query that runs fast. In fact, when you've got frequently used queries like get by ID or get by name, precompiling them can give you a significant performance boost, especially as your data and traffic grow. Alright, and now that we've tackled compiled queries, it's time to dive into the last cool feature of EF Core, especially if you are dealing with bulk operation. Now, starting with EF Core 7 and later versions, including EF Core 8, you can take advantage of some powerful batch update and delete capabilities directly in your code, and you no longer have to resort to custom SQL for common operations like updating and deleting records in bulk. Let's say we have a scenario where we want to update the prices of products under a specific category. Before EF Core 7, doing this efficiently would require either loading all those products into memory or writing raw SQL. But now, thanks to execute update async, we can perform this in bulk and update the database directly without pulling all those entities into memory. Let's check out this example. What's happening here? Well, we are using execute update async to efficiently update the prices of all products in a particular category by a certain amount. And this means EF Core is generating an SQL update statement behind the scenes, and it's doing it in one batch. That's a huge performance boost, especially if you are dealing with hundreds or thousands of rows. This feature is a big deal because previously you'd have to either manually write raw SQL or look through each product, load them into memory, update them, and then save those changes back to the database. This not only adds complexity, but it's also slow and resource intensive. Now with execute update async, you can directly tell EF Core to perform that update in one go without the overhead of tracking the entities and without needing raw SQL. It's fast, simple, and perfect for bulk updates like increasing prices, adjusting inventory, or even marking certain records as inactive. So in this code, we first filter the products using where method to get only the products in the specific category. Then we call execute update async, which applies the operation we want. In this case, increasing the price. We use set property method to say take the current price and add the increased amount, and this directly updates the database with a single SQL statement. Also notice how we are passing a cancellation token as well. Just like with our other async operations, this helps us manage long-running database tasks by allowing the operation to be cancelled if necessary. Whether you're updating prices, inventory, or any other kind of bulk operation, batching with execute SQL raw or execute update async is a must for boosting performance. Alright, let's dive into the product controller to wrap up everything we have covered so far. This controller lets us showcase all the EF Core features we've worked on in a way that's easy to test and observe, especially when we simulate our queries and updates on Swagger. Here's the full product controller file, which will handle requests related to our product data. Each method here highlights different aspects of performance optimization, letting us see how smoothly they interact with EF Core's functionality. First, let's start with get products method. As you know, this method uses pagination along with the ASNO tracking and eager loading, allowing us to retrieve only the necessary records in an efficient way. It's perfect for scenarios where we are displaying a subset of data in the UI. Next method is get product by ID. This endpoint demonstrates a compiled query by retrieving a single product based on product ID. The compiled query improves performance by optimizing how EF Core fetches data, especially helpful in scenarios where we are making frequent similar requests. And finally, the update product method uses batch processing to increase prices of all products in a specified category by a set amount 1000. The execute update async function ensures that we are processing all the updates directly in SQL without loading and modifying each item individually, which is more resource efficient. Alright, now that we've set up the core functionalities in Product Controller and optimized it with EF Core performance techniques, let's talk about testing all of these endpoints with Swagger. As I mentioned before, with Swagger, you can test each of these endpoints individually to see how all these performance optimizations really make a difference, whether you are retrieving data, updating prices, or querying single products. Each request highlights how these performance tweaks like as-no tracking, compiled queries, optimized pagination, and batching with execute update method. All these features help boost your EF Core's efficiency when handling CRUD operations. To effectively test these endpoints, you'll need a properly structured database with data that represents real-world scenarios. This will help you see how each endpoint performs in a practical setup. For more guidance, I'll show you the database structure I'm using here, which you can replicate for testing purposes. And for an even easier setup, you can access the complete project on my GitHub to get everything up and running. You'll find the link to the repository in the description below, where you can download the project files and set up your database environment. And this will let you experience each performance tip in action and see how they truly improve EF Core's CRUD operations. Okay, in this video we covered 7 essential topics to enhance your EF Core performance in practical scenarios. Lazy connection string initialization for efficient resource management, disabling lazy loading to control data loading and improve response times, as-no tracking for faster read operations by avoiding change tracking, eager loading with include to efficiently load related data, compiled queries for faster execution of frequently used queries, bulk operations with execute updates to handle multiple updates at once, and finally optimized pagination to retrieve data in a memory efficient way. These strategies combined will help you optimize EF Core performance for CRUD operations, reduce unnecessary load, and achieve a smoother application behavior. If you found this tutorial helpful, please give it a thumbs up, subscribe, and hit the bell icon so you don't miss future content on advanced programming topics. And as always, thank you for watching, keep coding and optimizing, and I'll see you in the next one.